Alright, so welcome to the third video on Bayesian games today. This is figure 284.1 from the book, and what this figure says is that there are three possible games that are being played, three states of the world. State alpha, beta and gamma. Player 2 doesn't know whether the state of the world is either. So player 2 can receive one of two signals. One signal will tell player 2 that the state of the world is either alpha or beta, with a probability 3/4 on alpha and a probability 1/4 on beta. Or player 2 could receive a different signal, which would tell player 2 for sure that the state is gamma, and that this game is being played. Player 1 can also receive one of two signals. Either player 1 could receive this signal, which tells player 1 that the state is alpha, or player 1 could receive a different signal, which would tell player 1 that the state of the world is beta with a probability 3/4 and gamma with a probability 1/4. We'll call this type of player 1 player 1 type 1. This is player 1 type 2 that has this information. Player 2 type 1 has this information, and player 2 type 2 has this information. Let's look at the Nash equilibria in all three games. Okay, so state beta and state gamma are exactly the same payoff function, and here the two Nash equilibria will be LL and RR. And here there's only one Nash equilibrium, RR. And what happens in this game is that this state, the probability, the chance that this state exists, will infect the whole game. And so what we want to do is to show that RR is the only Nash equilibrium of this game. Okay, we want to show this. So far in Bayesian games, what we've done when we have always only checked whether something is Nash equilibrium. This exercise is different in that we are going to try to show that this is the only Nash equilibrium. So we're going to find all Nash equilibria of this game in some sense and show that that can only be RR. We're actually not going to use any different mechanism to find all Nash equilibria of this game. What is actually going to end up happening is, well, one, what I want you to understand is that this is a fundamentally different question we're answering to questions we've answered before. It's different from the other questions we've answered before because we're trying to show that this is the only Nash equilibrium. The methods we'll use will be exactly the same. What we'll show is that player 1 type 1 has a particular dominant strategy, which player 1 type 1 will always play. Player 2 type 2 will respond to that, and so on. So let me show you what happens. Actually, player 1 type 1 you can already see. Player 1 type 1 has a dominant strategy of playing right. And that's going to infect everything else. Okay. So if you want, you can take a pause here and stab the problem and see if you can solve it. If not, I'm next going to show you the mechanism of how to solve it, and I'll give you another pause then. For now, let me erase this. In order to show that the game will have only one Nash equilibrium, the first thing we must do is to draw out the expected payoff boxes for each of the 4 players here. Player 1 type 1, player 1 type 2, player 2 type 1, and player 2 type 2. You can probably skip over the next 10 seconds. Still going to be drawing this. Okay, well, I did my best. So let's say this is player 1, type 1, player 1, type 2, player 2, type 1, and player 2, type 2. Player 1 can play left or right, left or right, left or right, left or right. And what's going to populate the columns is the strategy that's chosen by player 2, or the actions rather chosen by both types of player 2. So you can have LL, LR, RL, or RR. LL, LR, RL, RS, those are my initials, RL, RR. LL, LR. And I'd already calculated this in India, but you guys, we've done a couple of examples now of games in which you're calculating the expected payoffs in these boxes. So I trust you to be able to do that. If, however, that is an issue, we can talk more about it during the Zoom meeting for the recitation. So this becomes 2, 3, 2, 3, 0, 1, 0, 1, 2, 0, 3 by 2, 1 by 4, 1 half, 3 by 4. Oh, actually, why don't you guys try and fill out the rest of it on your own? So pause this video now, try and fill it out on your own. It'll take a little bit of time, but it will give you practice. And I really think that you guys should try to do that instead of just copying. So pause the video, try it out, and yeah, meet me back here when you have those numbers. 0, 1, 2, 0, 3 by 2, 1 by 4, 1 half, 3 by 4, 0, 1, 2, 0, 0, 1, 2, 0, 0, 1. Okay. Let's just see what these numbers mean. So take this number for instance. What this means is for player 2 type 1, the expected value, so the expected payoff that player 2 type 1 will get from playing L, given that player 1 type 1 plays L and player 1 type 2 plays R, will be 3 by 2. That's what this number means. You can sort of figure out what the rest of these boxes mean because it's all analogous. Okay. Now we want to make the argument that RR is the only Nash equilibrium here. Okay. Let's look at player 1 type 1. 3 beats 2, 3 beats 2, 1 beats 0, and 1 beats 0. So R is a dominant strategy. Now we know that player 1 type 1 always plays R. If we know that player 1 type 1 always plays R, and we look at player 2 type 1's incentives, we know that player 1 type 1 will always play R and not L, right? That means that player 2 type 1 knows that these are its only options, right? Because these will never happen. If these are player 2 type 1's only options, then player 2 type 1 would best respond by playing R, right? Because 3/4 is greater than half and 1 is greater than 0. Now we know that player 2 type 1 always plays R. Let's look at player 1 type 2's options. Right? Player 2 type 1 always plays R, which means that player 1 type 2 will also always play R. Which means that player 1 type 1 always plays R, player 2 type 1 always plays R, and player 1 type 2 always plays R. So when we're looking at player 2 type 2's preferences, player 1 type 1 plays R, player 1 type 2 plays R, therefore player 2 type 2 should also always play R. And so the only Nash equilibrium of this game will be one where player 1 type 1 plays R, player 1 type 2 plays R, player 2 type 1 plays R, and player 2 type 2 plays R. Okay, end of video.